Welcome to this explainer. Have you ever wondered why a roller coaster feels absolutely thrilling, like your stomach is dropping out, but a high-speed bullet train going way faster just feels perfectly smooth? Well, today we're going to unpack exactly why that is, using a brilliant framework called the concept-first teaching methodology. If you're studying kinematics for the Cambridge IGCSE Physics 0625 syllabus, or really any physics curriculum, we need to talk strategy. You see, memorizing a giant list of formulas just isn't going to cut it anymore. It's like trying to win a football match by just memorizing the rule book instead of actually learning the tactics. We need to completely rewire how we approach speed, velocity, and acceleration so that they become totally intuitive. I am so excited to guide you through this game plan because once you see the mechanics of motion through this specific tactical lens, the entire subject starts to just click into place. And hey, before we dive into the playbook, make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Let's get started. Okay, here is our tactical roadmap for today's session. We're going to cover 1. The motion starter. 2. The 4-step gateway. 3. Physics vocabulary. 4. Real-world applications. 5. Avoiding exam traps. And finally, 6. A quick recall checklist. Let's jump right into Section 1, the motion concept starter, making the idea feel necessary. So we begin our strategy not with some memorized wording or a super dense textbook definition. Instead, we're going to shift our minds into active problem-solving mode. Too often, students just accept terms like velocity or acceleration as decorative vocabulary words. But physics isn't a vocabulary test, right? It's a study of actual reality. Before you even think about writing down an equation like V equals d over t, you need to stop and ask yourself, what physical effect, measurement, or prediction actually depends on understanding speed, velocity, and acceleration? Why do we care? Well, by starting with this simple, fundamental question, the underlying ideas become an absolute necessity. You quickly realize that we literally need these concepts to predict exactly when two cars on a track will collide or to figure out exactly how much force is needed to safely launch a rocket into orbit without destroying it. This approach makes you far less dependent on just memorizing the words and infinitely more capable of reasoning your way through completely unfamiliar exam scenarios. You're thinking like a physicist, not a robot. Moving on to Section 2, the 4-step gateway, a micro-gateway into bigger scientific patterns. The concepts of speed, velocity, and acceleration aren't just isolated random topics. They actually act as a foundational micro-gateway into much broader scientific patterns across all of physics. If you can master exactly how to explain motion, you can master almost anything the syllabus throws at you. To achieve that top-tier mastery, I want you to follow these 4 linked steps. It's an unstoppable tactic. First, identify the quantity or phenomenon. Second, state the relationship involved. Third, explain the underlying physics. And fourth, connect it to an observation or a real device. Following these 4 linked steps is absolutely critical in IGCSE-style physics, and here's the secret as to why. Examiners aren't just looking for a regurgitated textbook answer. They hate that. Top-tier answers must demonstrate both a profound understanding of the concept itself and a very clear application of it to the real world. This 4-step sequence ensures you hit every single mark on the rubric. Now for Section 3, building physics vocabulary, transitioning to precision. Bridging the gap between our everyday talk and strict scientific language is totally crucial here. Look, we all know what fast means in everyday life, right? But in a Cambridge exam, saying something went really fast just doesn't cut it. We have to transition to absolute precision. On one side, we have everyday language. Those are your concrete examples and your initial rough observations. On the other side, we have true physics vocabulary, symbolic relationships, strict definitions, and clear cause and effect chains. This brilliant comparison illustrates that you should introduce those symbolic relationships only when you are absolutely ready, after you truly grasp the everyday concept. You want to always insist on cause and effect rather than just reciting isolated facts. For example, an object doesn't just magically speed up. A resultant force causes an acceleration, which then changes the velocity over a specific period of time. See the difference? That is the exact precision we are aiming for. And to keep getting these highly strategic breakdowns, subscribe to our YouTube channel, Ace the Exams, at @theacetheexams_IGCSE to excel in your Cambridge examination. Now, speaking of precision, we absolutely have to talk about graphs. Graphs are where so many students drop easy marks. When you're dealing with graphs, always stress what the slope, the area, the direction, or the overall shape means physically. If a topic involves graphs or even fields, forces, or waves, the crucial takeaway is that mathematical features must be directly linked back to a physical reality. The area under a speed-time graph isn't just some boring geometry calculation of a triangle. It represents the actual physical distance that object traveled in the real world. The slope isn't just rise over run, it's the physical acceleration. Always link the math directly back to the physical effect.
Let's look at Section 4, Real-World Applications, where you use it outside the classroom.
Physics is literally happening all around you, every single second, and the examiners desperately want to know that you realize this. Ideas derived from speed, velocity, and acceleration appear absolutely everywhere. Just look at this list. We're talking experiments, engineering, safety and transport, energy systems, communications, medical technology, and even astronomy. To really lock down this topic and secure the highest grades, you must always be able to name at least one real situation from these fields and explain why the physics helps us predict or improve actual outcomes. Whether it's designing crumple zones for car safety to reduce sudden lethal deceleration, or calculating the exact orbital velocity of a satellite so our global communication systems don't crash, these concepts matter. They aren't just paper exercises. They build our modern world.
Time for Section 5, Avoiding Common Exam Traps. Safest methods versus common weaknesses.
Understanding the physics is fantastic, honestly, but translating your knowledge into perfect marks on exam day requires knowing exactly what the examiners are looking for, and perhaps more importantly, what they actively penalize. This is where we outplay the defense. A massive weakness I see all the time is a student simply writing down a correct formula without explaining the variables, or quoting a process without linking it to any physical effect. Just writing A equals V minus U over T without any context, that's a huge trap. The crucial point here is to avoid simply quoting a process. Instead, you counter those classic errors by keeping your answer tightly connected to cause and effect reasoning. The safest method, your absolute gold standard game plan, is to provide the definition, state the relationship, explain the underlying physics, and then apply it to the scenario. If you build your answers this way, you are virtually bulletproof against losing those easily dropped marks.
Finally, we reach Section 6, Quick Recall Checklist. Secure your knowledge for the exam.
Let's anchor everything we've learned today with a rapid-fire checklist perfectly designed for those tricky short answer and structured questions. Think of this as your final system check before exam day. Here are the 4 revision prompts you absolutely need for speed, velocity, and acceleration. 1. What is the core idea? 2. What changes physically? 3. What quantity or graph shows it? And 4. Where is it used in the real world? If you can confidently answer these 4 prompts aloud right now, without peeking at your notes, your grasp of this topic is highly secure. This structure forces you to recall the concept holistically, connecting the raw definition directly to the visual graph representation, and then straight to the real-world application. It's the ultimate study hack. And as you put this system into practice, remember to
subscribe to our YouTube channel Ace the Exams at acetheexams_IGSC to excel in your Cambridge examinations.
As we wrap up this explainer, I want to leave you with one final, provocative thought to chew on. If you had to define the key idea of kinematics using a clear, strict cause and effect chain right this very second, what real-life example would you choose to justify it? As you head into your next study session, ask yourself this exact question. Grapple with it. Don't just gloss over it. By doing so, you ensure you aren't just memorizing abstract formulas on a page, but truly understanding the incredible, dynamic mechanics of our universe. Keep questioning the material, keep applying that concept-first, tactical mindset, and you'll find physics to be one of the most rewarding and conquerable subjects you can possibly study. Thanks so much for joining me on this explainer, and I'll catch you on the next one.